Okay, so if we have an equation where it says there's a function where the domain is the set of all real numbers except the number, say 2, all right? So it's all real numbers except the number 2. Well, that means really there is only one value that the graph cannot be, and so it can be any value except value 2. Now, normally we have a function where if we have a linear function, 3x plus 5 over. Now, to get rid of this 2 value, we need a denominator that says x minus 2. That means when x equals 2, you would have a 0 value. So if the denominator equals 0, when x equals 2, then that function is a possible function. Yes, that is a possible function. What if it was a quadratic, like 7x squared plus 3x minus 1? Yes, we could have a quadratic, but we need a denominator, x minus 2, and that would be, it could be any function for that matter that allows for all values of x. So any polynomial such as 3x to the power of 4 minus 2 over, and we can't have x minus 2. Be careful though, sometimes you will have a square root value, and if you have the square root of, say, 3x plus 1 over x minus 2, this is true. We can't have x minus 2. We can't have a 2 value, but the square root means 3x plus 1 has to be a positive number. So it won't actually be the whole set of real numbers. We restricted our sets to where 3x minus 1, 3x plus 1 is going to be a positive value. So that's what we've got to watch out for. And while I'm talking about domains, let me just say that if the equation has another possible, let's go to the correct screen. If the equation has such as 3x plus 5, but it's got something else, x squared minus 4, that becomes x minus 2, x plus 2. That means we're not allowed to have negative 2 or positive 2, but the domain will be all real numbers except for positive 2 and except for negative 2. So it wouldn't be this function here, it wouldn't be this function here, but it could be earlier.